Hello everybody, welcome back to my YouTube channel. This is Hemashri studying in Sri Venkateshwara College of Engineering, currently pursuing my first year BE in Electronics and Communication. Today in this video, I'll be explaining about the operation of full wave rectifier. This comes under the subject Basic Electronics and the subject code is BBEE203. So let's start with the slide. Introduction. In introduction, let us know about rectification or rectifier. Rectification or rectifier nothing means it is the conversion of a AC signal into DC signal, that is from higher voltage to a lower voltage. Rectification, it has many applications. It is used in mobile fields and it is used in inverters and also in batteries, etc. Let us move on. Now let us learn about the full wave rectification. In full wave rectification, here the first picture depicts the circuit diagram of full wave rectification, where there is a primary binding, secondary binding, and in secondary binding we have two partitions and a transformer is used. The transformer used is nothing but the center tapped transformer, which is used to convert a higher voltage to a lower voltage. Here the input is a AC signal, that is 240 volt, which is reduced with the help of a transformer to approximately 12 volt, and this 12 volt is equally divided to the both the partitions of the secondary binding, and two diodes are used in a full wave rectification, that is diode D1 and diode D2, and a load resistor is connected to this circuit. There are two cases in full wave rectification. The first case deals with the positive half cycle of full wave rectification, and the second case deals with the operation of negative half cycle of the full wave rectification. So now let's learn about the operation of these positive half cycle and negative half cycle. So operation of full wave rectifiers. Before that, this center tapped transformer is used to reduce a higher voltage to lower voltage, where the higher voltage here is a 220 volt, that is the AC input, and it is reduced to 12 volt, which is divided equally to both diode 1 and diode 2. That is the reason they use a center tapped transformer to divide equally. Now this is diode 1. Mhm. This is P type and this is N type. So now the first case is positive half cycle. In positive half cycle with diode 1, positive is connected to P type. Since positive is connected to P type, it acts as a forward bias. Since it is in forward biases, it it acts as on switch, so there is a flow of current through diode 1. Whereas in the case of diode 2, negative terminal is connected to P type. Since negative terminal is connected to P type, it acts as a reverse biases. In reverse biases, the switch is open. In open switch, there is no current flow through it. Here is the thing. As you can see, in the D2, the switch is open, whereas in diode 1, the switch is closed. So there is a flow of current in diode 1 and there is no flow of current in diode 2. Diode 1 acts as a forward bias, diode 2 acts as a reverse bias. So this is the direction of the current that starts from the positive terminal and ends at negative terminal. So this is how the current flows through the diode 1 in positive half cycle, and the output of positive half cycle is also a positive output waveform. So let's move on to the negative half cycle. Now coming to the negative half cycle. In negative half cycle, this will be negative, this will be positive. This is negative, this is positive. As usual, this is P type, this is N type, and this is diode 1, and this is diode 2. Then this is the load resistor. This is the load resistor. In negative half cycle, in with respect to diode 1, negative terminal is connected to P type. Since negative is connected to P type, the diode 1 acts as reverse biases. Since it is in reverse biases, it acts as a open switch and there is no flow of current. Coming to the diode 2, positive is connected to P type. Since the positive is connected to P type, there is a forward biases. That means diode 2 acts as a forward biases. Since it is forward biases, the diode acts as a on switch. In on switch, there is a flow of current, and this is how it is represented. In diode 1, there is an open switch, so there is no flow of current. In diode 2, the switch is closed, so there is a flow of current through diode 2. So this is the direction of the current. So it starts from the positive terminal and moves here, here, and comes across the load resistor and end up in the negative terminal. So this is how the current flows in diode 2 for a negative half cycle. Here is a small circuit diagram that represents the negative half cycle, and in the previous slide also there was a small circuit diagram which represented positive half cycle. So here is a brief points on positive half cycle and negative half cycle. In positive half cycle, D1 acts as a forward biases and D2 acts as reverse biases. During negative half cycle, D2 acts as forward biases and D1 acts as reverse biases. That's it. Hope you guys found this video helpful. If you find this video helpful, please do like, share and subscribe. Thank you.